The Multicomp page has some interesting notes on how to make the serial port work on the FPGA. The BASIC that's inside of the computer only runs out the VGA and PS2 by default, but you can switch around the chip selects and have it go out the serial port. But Grant has a note here that if you want to make the function keys toggle between input and output, a little interface could be added for that. So that's what we're going to take a look in this video, is what it takes to do that. He says it's straightforward and be published at a later date. As far as I know, he hasn't published it. At least it's not on the Multicomp page, but we went ahead and did it. Here's the entity for that function inside of the microcomputer module. It takes in the function key, which is a momentary press when the key's pressed, and a clock and reset, and generates a latched version. This is the VHDL module itself. Called it toggle on function key, and as I said, it takes in the function key, a clock, a reset, and generates a latched version which toggles every other clock. It has intermediate variables of function delay 1, 2, and 3 for edge detecting on the button, and an output signal that's the loopback itself. The function clears on reset, and every single clock pushes through this 3-stage pipeline of the function FN deltas, and then does an edge detect, and we'll take a look at how the edge detect works in the video a little bit later on. Here's that function key toggle module linked inside of the, or loaded inside of the microcomputer itself. I'll leave a link to the VHDL code in the show notes. This requires 2 signals to be created in the microcomputer module, one to get the function keys and the other one for this particular key. The key functions are already defined inside of the VGA driver, and they're shown here as pins on the entity. They weren't brought out in the standard example, but you can see that they're here and already provided. It's just a matter of adding them back into the microcomputer entity itself. Really simple then to go and add into the microcomputer module the extra function keys so they show up there. Here's that function key module inside of the microcomputer module itself. Here's the mapping to the function key, and this uses F1 as the example. Clock, reset, and then the output, which is that latched toggled bit. The next thing that has to be changed is the chip selects, so that it uses that latched function key value to switch between the 2 addresses, and that's really all it takes to change between the serial and the display. This swap can be done on the fly. It looks like the software built into the card actually supports both of those in the initialization as well. Went ahead and took away one of the LEDs and are using that to see the toggle, so if I press the F1 key I can see it visually. It's important to me that the CRT screen comes up with the keyboard first, and so what we did for that was made sure that it was cleared, and that clear value was what was the initial value, and if you want to change, pressing F1 will switch over to the serial port at that point. The edge detect on the F1 button press uses 3 D flip-flops connected in series, and that input signal at every clock is moved through to the next stage. To detect an edge, then what you would do is take one of the outputs later in the stage and the stage after it, these 2 near the end here, and take one of those and invert it, and the other one, and then run it to an AND gate. And if you wanted to go on a different edge, you would move the inverter to the other part of the path. Basically, there's an inverter in the pre-stage, NOT gate, and in the final stage that shows a AND gate. Pardon my fancy video effects here. Yeah, and that'll create a single clockwise pulse when the edge is detected. The first D flip-flop is probably unnecessary, but if you've ever been bit by metastability, you would understand why you would have it there. That edge detect is then fed to a latch that toggles every other time. Basically a D flip-flop with an inverter connected back to the input pin. The toggle function is shown here when the clock or when the data in one are different, and it holds it and flips it every time that it gets that edge. Let's go ahead and run PuTTY on the serial port and connect up at 2400 baud, which is what the UART baud rate generator was set to. And sure enough, let's see what happened. 2400 baud. Open it. And we can go and type. Looks like I forgot to put the caps locks on. And if you put the cap lock on, wow, it works. So it was working now, or now it works. And serial's coming out of there. Of course, I pressed the F1 button to switch between the two, and that's what you see here. Let's go ahead and make that screen a little bit bigger so it's a little bit easier to see. Putty supports this pretty nicely. Also supports the ANSI escape sequences that Grants has built into the terminal emulator function, and so we'll be able to play with highlighting and color and things like that. We'll see how that works. But it looks pretty good. I mean, it's definitely coming out. This is a little program that prints stuff out. Now let's try sending some ANSI color code and see if it is supported by the hardware. It should be. And if we print that statement, it makes white on blue text. Here's a list of the ANSI different commands that you give it to do various different functions. I have a few of those off on Notepad, and the way to upload to the card is to copy from Notepad and then paste it by doing a right click inside the window. It looks like I grabbed a little more than I wanted to grab. Let's try that again. And that's blue, red on blue. Wow, not exactly a great color choice. There's probably a few other better choices in here we can do. Let's see what we get. The red on blue, okay. It's not as messed up as the previous line was. And let's try this color and see what it looks like. Click in the left window in putty and then right click, and it'll paste it in the screen, and then it persists over in that screen. And that's bright yellow on green. There's a few other options here. Here's going to be black text on the green. You can change just the foreground or background or both. Again, probably pretty obnoxious color. I'm really a fan of white on blue, like the screen up at the top, which I grabbed a little bit earlier. You can change just the background and leave the characters the same, as I said. So there's a lot of options. You can home the cursor back up to the top. Let's see how that works out. With all the other things on here, yeah, I think the cursor is up there. It looks like it. Yep, typing up there, and it shows up there. I did a list. That isn't affected by the fact that there are already characters there. There's another ANSI command to clear the screen, and it'll clear everything after the current cursor position. I think that's what this one is. And nope, that was a different one. I'm not quite sure which one that one was. I probably should have taken better notes over there. But you can see you could write some pretty fantastic menu systems and other kinds of things with this. Here's some of the other ANSI codes supported. Cursor home. And that's got a little string you send out to it with print command to clear it. There's quite a few of them here that are probably pretty useful, and I guess this is why the color computer was a color computer. It supported all of these sorts of cool little things. I guess that's where this came from. Not really quite sure. I'll probably have a little crib sheet somewhere where I've copied those off and have the ability to copy paste easily, but it can be copy pasted off the web page as well. It seems to work pretty good. I wasn't able to do a bunch of lines at the same time, but it did seem to, they all did seem to work, so they're pretty well supported here. Let's see, that looks like it cleared to the background color everything after that line, so that's a nice little command as well. Quite a few options here. Let's see what this one does. That one took the cursor back up home again. Okay, so combined with that and the clear, you could probably do something pretty nice as far as graphic stuff goes. And I think you can place the cursor anywhere you want on the screen basically with it. There's the clear after that. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.